Hello everyone. So before moving on to the concepts, first let's see some numerical problems. Okay, so that you are more comfortable in your concepts. So this is a very simple question. You have to find the expression of ICT, and for t less than 0, VCT is 0. Okay, although it is written 10 volt here, but you will consider it as 10 UT now. Why so? Because they have given this condition that your VCT is 0 for t less than 0. That means it is applied after t greater than 0 only. If it had been applied before t less than 0, then VCT would have been 5 volt, right? I have told you, like, if it would have been applied for minus infinity to 0, then steady state would have already reached. And if steady state would have reached, that means your VC would have been 20 by 40 into 10. That means 5 volt. But this is not the case. They have already given that VCT at t equals to 0 is for t less than 0 or t equals to 0 is 0 volt. Okay. Now you need to find ICT. Okay. So tell me, what is the value of IC at t equals to 0 plus? Tell me, what will be the value of IC at t equals to 0 plus? That would be 10 by 20. 10 by 20k, right? So it would be 0.5 milliampere, right? And what will be IC infinity? Tell me. IC infinity will be 0 only because the capacitor will be open circuited. So it will be 0. What is the time constant of the circuit? Time constant. Tell me. It is R equivalent into C effective. What is C effective? Yeah. So what is C effective? C effective is 4 microfarad. And what is R equivalent? R equivalent is 20k parallel with 20k, that means 10k. So your time constant would be 44 into 10 kilo into micro. So it would be milli. So 40 millisecond, right? So what would be your IC? Your ICT would be, at infinity it is 0. So it would be 0.5 e to the power minus t upon tau, that is 40 milli, and UT milliampere. I note IC0 e to the power minus t upon tau UT milliampere, right? Because this is milliampere, so we have written milliampere at the last, or you can write it like this into milliampere. Okay, so this is your ICT. Okay, now before going to the next concept, let's understand a simple concept of integrator and differentiator. What is integrator? Integrating. That means if you apply a step function, you should get a ramp. If you apply a impulse function, you should get a step. So this is what we mean by integrator. And what is differentiator? Just differentiating. If you apply a step, you should get an impulse. If you apply a ramp, you should get an step, right? So if they use the term RC integrator, okay, RC integrator, that means they are talking about this circuit, okay, RC. And if they use RC differentiator, that means they are talking about this circuit CR. Okay, you need to remember it. Okay, I will explain you the concept, but you should remember it. RC integrator means RC. RC differentiator means CR. Okay, so let's see one thing here. Let's just assume I apply a step input. Okay, to this circuit, if I am applying a step input, this is my input with respect to time t, obviously. So this is my input, V in. So if this is your input, what will be your output? I have explained. From 0 to 5 it will rise, right? Across the capacitor, initially it is 0 and eventually it will be equal to the input voltage only. So from 0 to 5 it will rise. So it will rise like something like this, right? So I should start from here, right? It will rise like this. Let's assume it is having some time constant tau equals to RC, right? Now what I am doing, I am increasing the value of RC. Okay, I will call tau 1. Okay, now what I am doing, I am increasing the value of time constant. If time constant is increased, that means the circuit becomes slow. High time constant means it will take more time to stabilize. That means circuit becomes slow. So it will reach 5 volt but after some time, right? So steady state will be reached after some time, right? Circuit becomes slow, right? So here this is tau 2. That is like R and C are changeable. I can say R and C are variable for now. Okay. So now this is tau 2. Okay. Let's not call it RC directly. This is tau 1. This is tau 2. Now now I have increased my time constant such that the response becomes linear. Okay. Nearly linear. You can't say completely linear. It becomes nearly linear. I think I should use different pen. So the response is nearly linear. Nearly linear. That means ramp. Look, if I am increasing my first my time constant was something, so response was like this. Then I am increasing my time constant, the response becomes slower. Then I am increasing more time constant, the response become more linear, right? As you increase time constant, here I am writing time constant increasing, that means response becomes more linear. Response more linear, right? So if you increase the time constant, your response becomes more linear, right? So for a unit ramp input, sorry, for a step input, you are getting response as ramp input. So isn't it acting like an integrator? You applied a step input, your time constant was so that the response was nearly linear. So isn't it acting like a uh, isn't it acting like a integrator? Because step is converted into ramp. You applied a step at output, you applied a step at output, you are collecting ramp input, right? So it acts as a it acts as a integrator, but the condition is at higher time constant, right? At high time constant. So at high time constant, where should I write? Here I should write at high time constant, at high 2. Okay, you will get it, right? So at high time constant, it is acting like a integrator. Okay, so eventually you just need to know if they are talking about RC integrator, that means you need to make RC circuit, and if they are talking about differentiator, you will make CR circuit. Now how it is a differentiator? Let's just assume you apply a step input again. Okay, you are applying a step input again. This is your V in. Okay, now tell me, how will the response look like? The response will be something like this, right? Initially V out will be V in only. Initially V out will be 5 volt, then eventually it will be open circuited, so V out will go down to 0. We have solved this circuit, right? Initially 5 volt, then this capacitor will be fully charged, so it will be open circuited, so it will go down to 0. So from 5 to it goes down to 0. So the response is something like this, right? Okay, I should use a different color of pen. So this is your output. Here I should have shown all three are output. Okay, you will get to know. So this is your V node for some tau 1 or some tau 1. Okay, now what I am doing, I am decreasing my time constant. I am decreasing my time constant. If you are decreasing the time constant, that means circuit becomes faster, right? If you are decreasing the time constant, that means circuit becomes faster. That means capacitor will be charged very fastly. I am decreasing my time constant. What I am doing, I am decreasing my time constant. That means your circuit becomes faster. Circuit faster. That means the capacitor will be charged fastly. That means output output goes down fastly, right? Output goes down fastly, and it will give you nearly impulse response, right? Let me show it to you. Output goes down very fastly. So just as you apply the input, okay, just as you apply the input, output goes down for a very low time constant. So this I will call tau2. This I will call tau2. Okay, and the response is very fast response, very fast, going to zero very fastly. Like you just apply the input and it goes to zero. For a moment it comes and then goes to zero. Are you getting my point? For a moment it is 5, then suddenly it is 0. You apply a 5 volt, okay, for a moment it is 5, then capacitor is charged to 5 volt, it goes down to 0. So goes down to 0 very quickly. Goes down to 0 very quickly, right? It goes down to 0 very quickly. So nearly impulse. Okay, but there here the condition was at high time constant, but here the condition is at low time constant. Okay, at low time constant. Okay, time constant is low, circuit becomes faster. That means capacitor is charged very fastly. That means if capacitor is charged very fastly, that means output goes down very quickly. Okay, so nearly it is an impulse response. So output goes down, output goes to 0 very quickly. So if you just differentiate the, you differentiate the step input, you get a, sorry, not ramp, you get an impulse response, right? So it is acting like a differentiator. So in conclusion, you just need to know two things. Integrator means RC circuit, differentiator means CR circuit. That's it. Okay, now let's see a question. So this is a question given that an input Vt equals to 100 t ut is applied to an RC differentiator circuit, with R value and C value. You need to find the maximum value of output. That means what is the circuit? CR. This is the circuit, right? CR, and this is V naught, this is C, and this is your V in. Your V in is 100 T UT. Now, can you do this by doing say initially capacitor is shorted, then it is open circuited, then I will write this equation y of infinity plus y of 0 minus y of. Can you do this thing now? No, you can't do, because here the input is not a step, it is a ramp input. And did I tell you any formula for ramp input and anything? No, I didn't tell you any formula. So we have to apply Laplace transform. There is no other way. Okay, Laplace transform. Only for step and impulse input, I will tell you how to solve it in time domain. For ramp input, we can't solve it in time domain. We have to apply Laplace transform. Okay, so just apply Laplace transform. Okay, so tell me, you have to find the value of V naught, right? So okay, let's just apply the Laplace transform in a good manner. Okay, so what I will do, I will replace the capacitor with 1 by Cs. This R will be R only, this will be V naught S, this will be V in S. So your V naught S would be R upon R plus 1 upon Cs into V in S. So it would be RCS upon RCS plus 1 into V in S. What will be V in S? V in S would be 100 by S square, right? What is the Laplace transform of TUT? It is 1 by S square. So it would be 100 by S square, right? So your V naught S would be 100 RC, 100 RC S upon RCS plus 1. Okay, now we have to break it down into two functions, right? So I will write 1 upon S and 1 upon SRC plus 1. So it would be SRC plus 1, so I have to make SRC. So that's how you break it down. What did I do? I just write 1 upon S minus 1 upon SRC plus 1. So if this SRC plus 1 goes here, I need SRC minus SRC here. So I wrote RC here. So SRC plus 1 minus SRC. So it would be like this. Okay. So the final expression would be 100 RC. Okay. One more time. 1 minus S upon 1 plus 1 upon 1 plus 1 upon S plus 1 by RC. Okay. So it would be 100 RC. Laplace transform of this would be ut. So I will write ut later on. Okay. 1 minus e to the power minus t upon RC ut. So this is the response, right? This is V naught t, right? Are you getting this point? I just applied Laplace transform and just converted it. What is the Laplace transform, inverse Laplace transform of 1 by S? That is ut. So this is ut written here. And what is the Laplace transform of this function? 1 upon S plus 1 by RC. It is e to the power minus t by RC into ut. So this is what I have written here. Now what is the maximum value of this? Maximum value. Maximum value. What will be the maximum value? You can differentiate it and put equals to 0. Okay. So at t equals to infinity, you will get the maximum value. Okay. Because at t equals to 0, what value you will get? At t equals to 0, this will be 1, you will get 0 value. This is not the maximum. At t equals to infinity, what will you get? At t equals to infinity, this will go down to 0. At t equals to infinity, this will go down to 0. So 100 RC you will get, right? That is V naught t maximum, that is 100 RC. Okay. So 100 into, what is the value of RC? RC is 5K into 4, 4 micro. So it would be 20 milli. 5 into 4, 20, it would be 5 into 4, 20, and micro and kilo, it will be milli. Yeah, so 20 milli. So it would be 2 volt. So that is the maximum value we will get. So that is the maximum value of output. Okay. So this is the question. So what did we do? First we need to know what is the RC differentiator circuit, that is CR. Now the input applied is step, right? If input applied is ramp. If it was step, we could have written the output expression just by one equation, V infinity plus V0 minus V infinity e to the power minus t upon 2. But we don't know that, so we have to apply the Laplace transform. So now we have to apply the Laplace transform and then we get the final expression. Now we know the final expression, so we can write the maximum value as well, that is 2 volt. Okay. Now this is the third question. You have to find the energy absorbed by the resistor in time interval from 0 to infinity. Okay. And it is given that initial capacitor voltage is 6 volt. Okay. What is this? Yeah. So initial capacitor voltage is 6 volt. Okay. So let's just assume the current through the resistor is, the voltage across the resistor is VR and the current through the resistor is IR. Okay. So in any question, if they are asking about the energy observed, okay, you never remember any formula. Never ever remember any formula. You just do one thing. They are asking about energy absorbed, right? Energy absorbed you will write. Then you will write time interval. They are asking from 0 to infinity. Okay. Then simply VRT into IRT. What is this? This is power, right? Into dt. This simple integration you need to do, and this will be your final answer only. Okay. This is very important. Sometimes people remember formula half CV square. For one time it is fine. Like what will be the energy absorbed by the energy stored by the capacitor? That would be half CV square. But if they are asking from the battery, what is the energy given by the battery? It wouldn't be half CV square. For that you will do voltage of battery into the current from the battery into dt. That's it. Voltage into current into dt. Now they are asking about resistor. So I am not writing any formula. Voltage into current into dt. That's it. Can I write the expression of VRT and can I write the expression of IRT? Yeah, I can. So tell me, what is the value of VR at t equals to 0 plus? Here we have 10 volt, here we have 6 volt, right? Here we have 6 volt. Initially we have 6 volt here. 10, 6, so VRT is 4 volt. What will be the value of VR at t equals to infinity? Tell me. 0 volt, right? Because the capacitor will be open circuited. If capacitor is open circuited, that means there will be no current through the resistor. If there is no current through the resistor, that means the drop will be 0 volt. So what will be the expression of VRT? It would be 4 e to the power minus t upon tau. Let's just write the value of tau. Tau is RC here, so it would be 8 second. Tau is simply RC, right? Initial voltage doesn't matter when you find the value of tau because everything will be shorted. So C equivalent is 2, R equivalent is 4, so it would be 8 second. Okay, so tau I have written here like this. Now tell me what will be the expression of IRT. So what is the value of IR at t equals to 0 plus? Here we have 10, here we have 6. So 4 volt by 4, that means 1 ampere, right? Or simply if you divide by it, if you divide this expression by resistance value, you will get the IRT. So let's just not apply the formula. What will be IRT? IRT would be VRT by 4, right? Voltage upon resistor. So that would be e to the power minus t upon tau ampere. This will be volt, this will be ampere. So now here I can write 0 to infinity. What is the value of VR? That is 4 into e to the power minus t upon tau. What is the value of IR? That is e to the power minus t upon tau dt. Now e to the power minus t upon tau into e to the power minus t upon tau. What will happen? E to the power minus t upon tau square. Now this square will come here, so it would be e to the power minus 2t upon tau. Okay, the square will not go here. Okay, sometimes people do this common mistake. This is simple 11th 12th class mathematics. E to the power minus t upon tau square, so 2 here, so 2 will come here. E to the power minus t2 upon tau. 2 e to the power minus 2t upon tau, not t2 mama, 2t upon tau, not t2. So e to the power minus t2 upon tau. Okay, so 4 0 to infinity e to the power minus 2t upon tau dt, right? Okay, now what will be the integration of this? That would be 4 tau by 2. Okay, you can integrate this. Simply the integration would be reciprocal of this value, tau by 2. Okay, integration of e to the power minus at from 0 to infinity dt is just 1 by a will come outward, e to the power minus at 0 to infinity. This value will be 0 and minus also will come. This value will be 0, this will be value minus 1, so it would be 1 by a only. Okay, so you can remember it as well. E to the power minus at into ut for 0 to infinity, it would be just the reciprocal of the coefficient of t. So 4 tau by 2, so it would be 2 tau. So simply 2 into 8, that means 16 joule. So this would be your final answer. So never ever mug up any formula for energy. Whenever they are asking for energy, we know only two formula: energy stored by the capacitor half CV square, energy stored by the inductor half Li square at steady state. That's it. That we studied in basics of network analysis. We have studied it. Okay, but if we are talking about energy stored by the resistor in a circuit, energy given by a battery in a circuit, then we will always apply this formula: expression of voltage, expression of current into dt. That's it. Okay, so now see this question. I want you all to answer this question on your own. You have to tell me the steady state value of v2 at t equals to, steady state value of v2. So v2 at t equals to infinity you need to tell. So at infinity what will happen? At t equals to infinity, the capacitor acts as a short circuit. Capacitor acts as open circuit, right? So this will be your circuit. 9 volt, 2 kilo ohm, 2 kilo ohm, 1 kilo ohm. This is open circuited. This is also open circuited. Right? And you have to find this value. This value is V2. Okay. So how much voltage will come here? 9 volt is here. 2 and 1. It will be divided in inverse proportion 1 by 3 into 9. So it would be 6 volt. Right? This would be 6 volt. Oh, sorry. It would be 3 volt. 3 volt, 3 volt. Let's just call this value as V1. Your V1 would be 9 into 1 by 3. That means 3 volt. Now we have 3 volt here and these two are open ended. Okay. Now tell me one thing, if this is ground, so this will be 0 volt. Okay. If this is ground, this is 0, this is 3, this will be 3 volt. That's fine. Now tell me what will be the potential of this point. Do you know the potential of this point? And do you know the potential of this point? Can you say it is 0? Can you say it is 3 volt? No, you can't say. They are open ended. Right? These two are open ended. Right? Open ended. So you can't define the voltage here. Right? Can't define the voltage. Can't define the voltage. So this is an important point. Okay. So now what is the condition now? The condition is this. There are two open-ended. They are acting as a open circuit, right? So we have replaced some component with open-ended. We have replaced some component with open-ended. So we can see those components, right? This is your 10 microfarad. This is your 10 microfarad and this is your 20 microfarad, right? And this is your potential V2. And here you can see. And that's fine. This is your potential V2, right? And here we have 3 volt. This is all happening at steady state. This is all happening at steady state. We have 3 volt and we have 10 microfarad and 20 microfarad. They are providing very high impedance. They are acting as a short circuit, but still they are there. So if two of the components are providing very high impedance, then we will simply divide the potential in inverse proportion, right? In like for capacitor we will divide the potential in inverse proportion, but for resistor we would have provided the potential in the proportion, right? So they are capacitors. So simply V2 at infinity would be 3 into 10 by 30. So that would be 1 volt. Are you getting this point? 9 to 1. So simply 3 volt. And 3 volt will be divided between 10 and 20. Although they are providing very high impedance, although they are acting as a short circuit, very high impedance, very high. This is also providing very high impedance, very high impedance. Right? Both of them are providing very high impedance. But if we have to divide the potential, how we will divide? In the component itself, right? Let's just assume you have a 5 volt here, okay? And there is this 1 mega ohm resistor, and here we have 3 mega ohm resistor. How much will be the current? 5 upon 4 mega. That means 1.25 microampere. Very low current. Very, very low current. But if they are asking what is the potential V2, what will you do? 3 by 4 into 5, right? So 5 into 0.75, whatever the answer we get, that will be your answer, right? 15 by 4 will be your answer. So even if they are very high, they are acting almost as a open circuit, but still we have to divide the potential somehow. So we have to divide in the proportion of the impedance provided by them. And when it is about the capacitor, we have to divide in the inverse proportion of the capacitance, right? Because the impedance provided by the capacitor is 1 by j omega c. So it is already inverse. So we have to divide it in the inverse proportion. So we have divided like 10 by 30 into 3. So it would be 1 volt. Are you getting my point? I hope you have understood my point. Okay, so this will be your final answer. 1 volt is your final answer. So V2 at infinity is 1 volt. Okay, so let's see this circuit. You have to draw the IC waveform. This waveform you have to draw. There is a capacitor that is initially charged to 12 volt. The capacitance value is 1 farad. Now the switching action is given. So what is happening? First switch S1 is closed. Then switch S3 is closed. This is what is happening. So first let's see the condition for t less than 0. Condition for t less than 0. What is happening? This is a okay. Wait. This is a capacitor 1 farad, that is 12 volt. Okay, this is open ended, right? Because switch is open. This is open ended. This is also open ended, and this is also open ended, right? Because switches are open. All these are open ended, right? 1 ohm and 2 ohm. All these are open ended, right? So this capacitor is open ended. Will there be any current? The current will be 0 ampere, right? Because complete circuit is open ended, no current. So the capacitor will hold its voltage. Since there is no current flowing out of the capacitor, since there is no current in the capacitor, it will hold its voltage. It will hold its voltage, right? So it is holding its voltage. Okay, so the capacitor is holding 12 volt here. Okay, now condition for t greater than 0. Condition for t greater than 0 but less than 3 seconds. Okay, so what is the condition? We have a capacitor of battery of 12 volt. One farad, 12 volt. One ohm and 2 ohm. This is open circuited, right? This is 1 ohm and this will be 2 ohm. Rest are open ended. This is open ended. Now we are talking about the current IC. Okay, what will happen? 12 volt battery and 3 ohm resistance. So equivalently, what I can do? A battery of 12 volt or a capacitance having a voltage of 12 volt and then a 3 ohm resistance is there, right? So this IC I am talking about, and this is 1 farad. What will happen? This is 3 ohm and this is 1 farad. What will happen? It will discharge. What will be the expression of IC? Tell me. ICT. From 12 to it goes down to, so sorry, the current at t equals to 0 is, t equals to 0 plus is, the current at t equals to 0 plus, the current at t equals to 0 plus 12 by 3, that means 4 ampere, and eventually it tries to go down to 0 ampere, right? So the expression would be 4 e to the power minus t upon 2. Tell me the value of 2. What is C equivalent? 1 farad. What is R equivalent? 2 plus 1, 3. That is 3 seconds. So from 4 to it goes down to 0. Okay. So it is trying to go something like this. From 4 to it is trying to go down to 0. ICT. from 4 ampere to, so tell me, time constant is 3 seconds. So nearly how much time it will take it to go down to 0? 5 to time, right? Nearly. That means nearly it will take 15 seconds. So at 15 second, it will be, the current will be 0. But what is happening? The circuit is changing at t equals to 3 seconds. The circuit is changing at t equals to 3 seconds. So what is the value of IC at t equals to 3 seconds? What is the value of IC at t equals to 3 seconds? This is the value of IC at t equals to 3 seconds, right? Right? This is the value of IC at t equals to 3 seconds. So value of IC at t equals to 3 seconds, that would be 4 into e to the power minus 3 by 3. That would be 4 into e to the power minus 1. So let me bring the calculator. So the value of current is 1.47 ampere. So it is not going down to 0. At t equals to 3 seconds, we are having 1.47 ampere current. So this is 1.47 ampere. But the capacitor doesn't hold its voltage. Sorry, the capacitor doesn't hold its current. It holds its voltage. Okay, let me make the circuit at circuit for t greater than 3 seconds. So what will happen? Circuit t greater than 3. Let me just copy it and then just paste it. Now this voltage is not 12, right? This voltage is not 12 because the voltage is also reduced. What is the expression of VCT? VCT is initially 12 volt, then it goes down to 0, from 12 to 0. So 12 e to the power minus t upon tau, and tau is 3 seconds. So this is the expression of VCT, right? So now if you draw the graph of VCT as well, it will nearly be the same only. This graph I can pick, I can copy, then I can paste. Right? VCT, talking about VCT. So initially it was 12 volt, then it goes down. So what will be the VC value at t equals to 3 seconds? 12 into e to the power minus 3 by 3, that would be 4.41 volt. So the capacitor voltage was trying to go from 12 to 0. It would have gone from 12 to 0 if this was the circuit forever. If this was the circuit forever, it would have gone from 12 to 0. But there is a slight change in the circuit now. Now at t equals to 3 seconds, this is charged to 4.41 volt, right? Now, and this is short circuited. So now what is your equivalent circuit? Now the circuit becomes something like this. Now this is shorted, so 2 ohm is gone. So this will completely be shorted. Right? 1 farad capacitor with the voltage of 4.41 volt and current of, this will be the current. Now tell me, what was the value of IC at t equals to 3 minus or 3 second, you can say. What was the value? That was 1.47 ampere. 1.47 ampere. What will be the value of IC at t equals to 3 plus? It would be 4.41 by 1. That means 4.41 ampere. And there is one note that I have already explained to all of you, that for a capacitor, VC t minus is equals to VC t plus. For a capacitor, VC t minus is equals to VC t plus in case of finite current. Infinite current is a completely different case that we have already studied for a finite current, right? But IC t minus is not equals to IC t plus, right? And here you can see that as well, right? This we have already studied, that for a capacitor, in case of finite current, voltage will be held, right? voltage will be held, but current will not be held. At t equals to 3 minus, it was 1.47 ampere. Then suddenly it goes up to 4.41 ampere. Now what will happen? The current will decay down, right? Now IC at t equals to 3 plus second was 4.41 ampere. Then IC infinity would be 0 ampere, right? Similarly for VC at t equals to 3 plus, VC at t equals to 3 plus was, basically this 4.41 will be discharged to 0, right? So 4.41 volt, and then VC at infinity, it would be 0 volt. So if you want to write down the expression of ICT, now how will you write it? You are going to write from t equals to 3 second, right? From t equals to 3 second you are going to write. So like we have studied this formula, right? I of 0 plus I of infinity plus I of 0 minus I of infinity 0 plus, we should write e to the power minus t upon tau. This we have studied. Now this can be modified. Infinity will remain infinity. From some time you are starting, right? 3 plus infinity e to the power minus t minus that time by 2. And here we would have written ut. Instead you will write ut minus 3. Okay, are you getting this point? If you are starting from some point, just instead of 0 put t naught. Here you will put t naught. So t naught is 3 second here. So you are starting from 3 seconds. So at 3 seconds we are having 4.41 ampere current, because this is 0, this is also 0, into e to the power minus t minus 3 by 2. Tau value is different now. Tau value is 1 u t minus 3 milliampere. Now this is your ICT for t greater than 3 seconds, right? So initially what was happening? The current was from 4 ampere, the current was going down. Then suddenly what happens? The current goes up to 4.41 ampere and then again goes down. So eventually it is going down to 0 only. Initially 4 ampere, then goes down. Then the switch is closed. Suddenly the current rises and then again goes down to 0. 4.41, and then eventually at infinity it will go down to 0 only. So if you make the graph of ICT for ICT graph, it is for t greater than 3 seconds. So what is happening? So like it will start from some value 4.41 ampere and then it will decay down to 0. From 4.41 ampere to decay down to 0. The time constant here is what? Time constant is 1 second. 1 second. Right? This is for t greater than 3 seconds. Okay, and let's make the graph of VCT as well. VCT. What about VCT? So for VCT was initially it was 4.41 and it is going down to 0 volt. So it will start from 4.41 volt, 4.41 volt, and will decay down to 0. Let's just make 4.41 a bit downward. From here we can make 4.41 volt and then decays down to 0. Right? This is happening in case of VCT. So now we can make the complete graph of ICT and VCT. So what is actually happening in case of ICT? This is the case of ICT. So initially we are starting from 4 ampere, then it goes down to 1.47 ampere. Okay, so we are starting from 4 ampere. This is our 4 ampere. This is our 4 ampere, and it goes down to 1.41 ampere. This is 1.41 ampere. Okay, 1.41 ampere. Then suddenly one switch is closed, so suddenly the value rises to 4.41 ampere. The value rises to 4.41 ampere, and then it decays down to 0. I think I should make more slow response. To 0. This is decaying down to 0 ampere. Now, why did I make it slow? Because here the time constant was what was the time constant? Here the time constant was 3 seconds. So it was a faster response, right? High time. Okay. Sorry. The time constant was high. That means it was a slower response. Okay. Time constant was high, right? So I should make it faster, and then the time constant was low. So if the time constant is low, faster it will reach to steady state. It will reach to steady state faster, right? So I should make it like this. So here time constant was 3 seconds, and here the time constant is 1 second, right? So it is the faster response. Faster response, right? Are you getting this point? Now let's make the graph for VCT. So what is happening in case of VCT? It is starting from 12 volt, then with the slow response it is going down to 4.41 volt. This is a slow response. It is going down to 4. Okay, I should use different color. This is a slow response. 4.41 volt. Then from 4.412 it goes down to 0, but with a faster response. With a faster response, right? So here the time constant was, and this should also be given. This is t equals to 3 seconds. This is also t equals to 3 seconds. This is 3 seconds. This is also 3 seconds. Here the time constant was 3 seconds, and here the time constant was 1 second. So it is also a faster response. Faster response. So I hope you have understood the concept. What is happening in the circuit? First, the resistance was 3 ohm, so the total current was 4 ampere. So from 4 ampere we were decaying down, but suddenly the switch was closed here, so the total resistance becomes 1 ohm. So the current rises up to 4.41 ampere, but the capacitor is holding its voltage. If it was 4.41 volt here, it was certainly 4.41 volt here as well. So the capacitor is holding its voltage 4.41. So the current becomes 4.41 by 1. That means 4.41 ampere. So now this 4.41 ampere current becomes, and now the voltage will go down from 4.41 to 0. So also the current will go down from 4.41 to 0 ampere. So 4 to some value 1.41 ampere, then suddenly rises up to 4.41 and then goes down. But the capacitor holds its voltage, so 12 to 4.41, then again goes down to 0, but the speed is changing. First the speed was t equals to 3 seconds, here the speed is t equals to 1 second, that is, sorry, tau equals to 1 second, that means time constant is low, so faster response will have. So this will be the waveform. So this was a very, very good question. Okay, let's move on to the next question. We have to find the voltage across the capacitor at t equals to 5 microsecond. Okay, this switch is closed at t equals to 0, this switch was opened at t equals to 0. So that means this switch was closed for t less than 0. So let's make the circuit for t less than 0. Or always while solving a numerical problem, always see the switch condition. Always start from t less than 0. That means always start from t equals to minus infinity. I have seen many of the students starting from t equals to 0. Never start from t equals to 0. Always start from t equals to minus infinity, because you have to take the initial condition in action as well. Okay, and initial condition should be there as well. Okay, so always start from t equals to minus infinity. Okay, so circuit at t equals to minus infinity, or sorry, circuit for t less than 0. Circuit for t less than 0. So this will be open circuited. So only this 1 ohm will not come in action because this is open ended. So only one end of this will be open ended. One end of this will be open ended. So it will not come in action. Only this 2 ohm will be there. And here we have 1 volt. This 2 ohm is there, and here we have this 10 microfarad. 10 microfarad. Okay, and this is the voltage value. We will call it VC. Okay, we are calling it VC. Okay, so even tell me one thing. We know that at a steady state the capacitor is going to be open circuited and voltage across the capacitor is going to be 1 volt. But tell me one thing, will it take any time to be stabilized to 1 volt? Will it take any time to stabilize to 1 volt? This is not a matter of concern for the question. Okay, I am just talking about the concept. Let's talk about the concept. You are applying 1 volt here. Okay, so how much time it will take VC to go up to 1 volt? You applied 1 volt here. How much time it will take for VC to go up to 1 volt? 0 second. Why so? Just see what is the current at t equals to minus infinity. Current at t equals to minus infinity. This is not a matter of concern for the question. You can solve the question, but I am just talking about the concept. What is the current at t equals to minus infinity? This will be completely short circuited, right? This will be shorted. This 2 ohm will not come in action. The current will be 1 by 0, infinite, right? The current will be infinity. So if there is infinite current, that means capacitor will change its voltage immediately, right? That means impulse current, I can say impulse current. So capacitor will change its voltage immediately. So how it will change? Simply 1 volt is there, it has to be 1 volt only, right? It can't stay at 0. Initially it is 0. If this is 1, it has to stay at 1 volt. Why? To obey the KVL, right? If there is 1 volt, here also there has to be 1 volt. To obey the KVL, it has to be at 1 volt, right? Are you getting my point? So if they had made the circuit like something like this, that if they could have made it like this. No, not like this. They would have simply said that the switch is closed at t equals to 0 minus and it is opened at t equals to 0. They could have said the switch is closed at t equals to 0 minus and it is opened at t equals to 0. Okay. again the answer would have been same. They don't need to close the switch at t equals to minus infinity. Why so? Because the capacitor is getting up to 1 volt in no time. It is not taking any time. Okay, 1 volt is reached very quickly. Okay, so Vc minus infinity is 1 volt. And why so? Because the current is infinity. The current is impulsive, right? IC minus infinity, IC minus infinity is infinite ampere. That means impulsive current. So it is immediately charged to 1 volt. So basically it will remain at 1 volt only. So VCT will always remain at 1 volt. So like there will be no transient. In previous analysis, I have made the circuit like this, right? But there will be no transient this time. It will always be at 1 volt. Okay. This is what VCT is. Okay. It will always be at 1 volt. Okay. Now circuit for t greater than 0. Now coming back to the question. Circuit for t greater than 0. I am taking every question which has some meaning. Okay. Not like blindly we are solving any question. Every question is having some meaning. I hope you are seeing this as well. Okay. So here we have 3 volt input, 3 UT. Then we have some resistance. Then we have some more resistance. And then we have the capacitance. Value of capacitance is 10 microfarad, which is charged to 1 volt. This is 10 microfarad. This is charged to 1 volt. We are talking about VC, right? This is 2 ohm. This is 2 ohm and this is 1 ohm. So tell me, what is the value of VC at t equals to 0 plus? The same as VC at t equals to 0 minus. Because now the current is not 0. What is the value of IC at t equals to 0 plus? Tell me. What is the value of IC at t equals to 0 plus? Yeah, this would be a good question. What will be the value of IC at t equals to 0 plus? 2 ampere. Right? Because this will be replaced with a 1 volt battery. If this is 1 volt, this is 3 volt. So 2 by 1, that means 2 ampere current is flowing. And since 2 ampere current is flowing, so this is 1 volt. Okay, wait. This will be replaced with a battery of 1 volt. Okay, so 2 minus 3 minus 1, that means 2 ampere current is flowing. This 1 volt, so this will take half ampere as well. So the current would be 1.5 ampere. Okay, IC at t equals to 0 plus. This would have been very good question actually. So IC at t equals to 0 plus would have been, if I am talking about this current IC, so IC t at t equals to 0 plus would have been 1.5 ampere. Why so? 1 volt is there, so this 1 volt will come here at t equals to 0 plus. Here 3 volt, so 3 minus 1 by 1, that means 2 ampere. Now this 1 volt will go here as well, so 1 by 2, that means it is taking 0.5 ampere current. So from 2 ampere current, it is taking 0.5, so it will have 1.5. Getting my point? So IC at t equals to 0 plus would be 1.5 ampere, right? Okay. And VC at t equals to 0 plus would be 1 volt only. Since the current is finite, that means it will hold its voltage. So it is holding its voltage, that is 1 volt. Now what will be VC at IC at t equals to infinity? Means steady state. Steady state means open circuit. Open circuit means 0 ampere current. Now what will be the VC value at t equals to infinity? This will be open circuit. So this 3 volt will be divided between 1 and 2. So it would be 2 by 3 into 3. That means 2 volt. What is the expression of VCT? Expression of VCT is, at infinity we are having 2 and 2 minus e to the power minus t upon 2 ut. You can write down the formula and then write down the equation. Since I am very much comfortable with the formula, so I can directly write down the equation. Okay, at t equals to 0 it is giving me 1 volt, and at t equals to infinity it is giving me 2 volt. I just use that formula, 2 plus 1 minus 2 e to the power minus t upon 2. It will give me 2 minus e to the power minus t upon 2. This is what I used here. Okay. And what is the value of tau? In this question, what was the value of tau? In this scenario, what was the value of time constant? What will be C effective here? What will be C effective? I want to know what will be C effective. 0 farad. Why so? Because for finding the time constant, we will short circuit the voltage source. We are shorting the voltage source. So if we are shorting this voltage source, this effect of capacitor will be gone. So C effective would be 0 farad and R effective would be, sorry, R equivalent would be 2 ohm. So basically your time constant would be 0 second. Also you can see immediately it is stabilized. Immediately, just as we apply the voltage, it is stabilized. So immediately it is stabilized, so time constant is 0 second. Now in this case, what is the time constant? Here the time constant is tau is, what is C equivalent? That is 10 microfarad into what is R equivalent? R equivalent is 2 by 3. So time constant is 20 by 3 microsecond, right? 1 ohm, 1 ohm. So 2 by 3, 20 by 3 microsecond. So this is the time constant, and this is the expression of VCT. That's what we needed to find. Yeah, find the voltage across the capacitor. Okay, you need to find the voltage across the capacitor at t equals to 5 microsecond. Okay, so we need to find Vc at t equals to 5 microsecond. So 2 e to the power minus 5 micro upon 20 by 3 micro. So let me just solve this equation. This 20 by 3, 15 by 20 plus minus e to the power e to the power plus minus plus 2, it would be 1.52 volt. Okay, so that's your final answer. So let's move on to this question. The capacitor voltage, initially the capacitor voltage is 4 volt, then switch is closed at t equals to 0 second. We should have written it. The switch is closed at t equals to 0 second. You have to find the charge lost by the capacitor from t equals to 25 microsecond to 100 microsecond. Charge lost by the capacitor from t equals to 25 microsecond to 100 microsecond. So what you will do, first you will find the voltage across the capacitor. If you know the voltage across the capacitor, you can find the voltage at t equals to 25 microsecond. You can find the voltage at t equals to 100 microsecond. So then from voltage you can find the charge. So you can find the charge at t equals to 25 microsecond. Then you can find the charge at t equals to 100 microsecond. Then you will know what is the charge lost. Okay. So just write down the equation of VCT. Let's just call this as VC. So VCT would be, simply it will discharge from 4 to 0. So 4 e to the power minus t upon tau. Now tell me what is the tau? Ut. What is the value of time constant? That would be RC. So 5 micro into 5, that would be 25 micro second, right? So what will be the value of VC at t equals to 25 microsecond? That would be 4 into e to the power minus 25 micro upon 25 micro. So that would be 4 by E. So let me solve it. That would be 4 by E. So 1.47 volt. Okay. What will be the, so here you know the VC value at t equals to 25 microsecond. Now tell me what will be the QC value at t equals to 25 microsecond. Q equals to CV, right? So QC value will be value of capacitance, that is 5 micro into 1.47 volt. So into 5, that would be 7.36 micro coulomb. Okay, so that is the value of QC at t equals to 25 micro. So this is equation 1, I can say. Now what will be the value of VC at t equals to 100 microsecond? That would be 4 into e to the power minus 100 micro by 25 micro. So it would be 4 into e to the power minus 4. I guess it will be nearly equals to 0. So that is 0.073 volt. Okay. So 0.073 volt. From here you can find QC at, okay, next page I will write QC at t equals to 100 microsecond. That would be CV. So C value is 5 microfarad. 5 microfarad into 0.073. 0.073. That would be 0.37 microcoulomb. Okay. So what is the charge lost? Right? Charge lost. So initially it was 7.36. This is equation 2. So from 7.36 to we go to the value from 7.36 microcoulomb to 0.37 microcoulomb. So nearly it is 7 microcoulomb. So we have lost nearly 7 microcoulomb charge. Easy question. Just they could have asked the voltage lost. What would be the voltage lost? It would be 1.147 minus 0.073. So the voltage loss would be 1.074. Okay. So but they didn't ask that 1.074. So into 5 if I do get 5.37. Wait a second. Okay, yeah, there was one error. The voltage loss would have been 1.47 minus 0.073. So it is coming out to be 1.397 and into the capacitance value. What is the capacitance value? Into 5. So into 5. So it would give me 6.98. So nearly we would have got 6.98 microcoulomb. Okay. So nearly 7 microcoulomb we have lost. So first you can find the voltage lost, then from there you can find the charge lost, or when you find the voltage at some particular point, you can find the charge at that particular point. Then at the other point you find the voltage, and at the other point you find the charge, and then you subtract them, so you can know the charge lost. So this much amount of 7 microcoulomb charge is lost by the capacitor. Okay. So this is a very good question. This will be the last question of this lecture. Okay. So we have solved many good questions. So let's make the circuit. This was a gate question, so it was given in this theory manner only. So a resistor and capacitor are connected in series to a 10 volt DC supply through a switch. Okay. So resistor and capacitor are connected in series. They can be connected in this way as well, and they can be connected in this way as well. Since they have not specified, we can take any circuit. So let's, for comfort, I will take this circuit R and then the C, just for comfort, no no other reason. So R and C are connected in series. Okay, both are connected in series. Okay, a 10 volt DC supply through a switch. Okay, 10 volt DC supply through a switch. The switch is closed at t equals to 0. Okay, why? The switch is closed at t equals to 0. The capacitor voltage is found 0 volt at a time t equals to 0.42. This is R, this is C. This is VC T. VC at t equals to 0.42 is 0 volt. Okay. The absolute value of percentage change required in the initial capacitor voltage if zero crossing has to be happen at t equals to 0.22. What is the meaning of this line? For this circuit, if you are getting 0 volt at t equals to 0.42, that means at t equals to 0, the capacitor voltage is some x. It is not 0, because if at t equals to 0, if it was 0, then it would have charged to some point, right? From 10, initially it is 0 and then it will try to go down to 10. But if it was initially 0 volt, if VCT at t equals to 0 was 0 volt, then at t equals to 0.42, it would have gained some value, right? How much value it would have gained? 10 into 1 minus e to the power minus t upon tau. So 0.4 by 1, because 0.42 and tau will get cancelled. So this much of value it would have gained. So the value would have been 0.4 plus minus e to the power minus 1 plus minus into 10. So it would have gained 3.92 volt, right? But this is not the condition. So that means there has to be some initial voltage. We don't know that voltage, but there has to be some initial voltage. Also, currently we know the voltage. It has to be 3.92 volt, right? But let's just assume we don't know. So there has to be some voltage, some x. It is some negative value, some negative value, some negative value. Why it is some negative value? Because 10 volt will charge the capacitor. From some negative value, it will go up to 10 volt, and like it will go something like this. From some negative value, it will go to 10 volt. So this will be the VCT graph. Now I can draw it more clearly here. It will start from some point and will go up to 10 volt. Let me pause it and make it. Okay, so this is the graph. So some x value, this is some negative value, you are starting, and 0 voltage you are getting at 0.42. Okay, and then you reach the steady state. This steady state is 10 volt. This is not a matter of concern though. Okay, this is not a matter of concern. This is 10 volt. Okay, you reach the steady state 10 volt. Now what the question is saying, that the absolute percentage change required in the initial capacitor voltage if the zero crossing has to happen at 0.22. So now you want this zero voltage should be here at 0.22. You want this thing. Okay, you want this thing at 0.22. You want to get zero voltage. You are not changing the RC value, you are not changing the time constant. So you will reach the steady state at the same time only. You will reach the steady state at the same time only. But if you want to reach the steady state at the same time, no change in RC, no change in time constant, no change in time constant. Time constant is the same. So steady state will be reached at the same point. But if you want zero crossing at 0.22, that means you want VC value to go to 0 volt at 0.22. That means you have to start from something up, right? Like let's assume x value is -4. I am starting from -4 and going to 10. 0 is happening at 0.42. Now I am going to 10 only, and I want 0 to happen at 0.22. That means I have to start something from up, no? Right? I have to start something from up. So I don't know from where I will start, but let's assume this value is 0. This value is x1. Okay, this value is x, this value is x1. Time constant is the same. Okay, so we can write down the VCT value. VCT value for this case, initial value is x, right? And it will go up to 10 volt. So 10 plus x minus 10 e to the power minus t upon 2. Given, what is given? At t equals to 0.42, VC t is 0 volt, right? 0 equals to x minus 10 e to the power minus 0.4. So from here you will get the value of x. That let me see. So the value that you are getting is 4.91 volt. Okay, x1 value is you are getting 4.9 minus 4.91 volt x value. Okay, so now you want, now what do you want? Now you want VC at t equals to 0.2 to go down to 0 volt, right? You want VC at t equals to 0.2 to go down to 0 volt. That means what do you want? What is the expression of, now what will be the expression of VCT? It will be changed from 10 is the steady state value, x1 minus 10 e to the power minus t upon 2. You want it at 0.22. So 0 equals to 10 plus x1 minus 10 minus 0.2, right? From here you will get the value of x1. You will start from some up value. Now your initial voltage is x1. Then previously your initial voltage was x. Now your initial voltage is x1. So you are starting from x1. Then for the same time constant, you are going to 10 volt. Okay. So what will be the value you are getting? Into 10. Let me recheck. Minus, and then this value is minus, and then we will have a plus. The value that you are getting is minus 2.21 volt. Okay. So now what is the percentage change? So the percentage change in capacitor voltage. What is the percentage change in capacitor voltage? We can simply take the magnitude, or if you want to take the negative value as well, you can take the negative value as well. Minus 4.91. Sorry, you should start like this. Final value minus initial value, like this. Okay. Like, what do you mean by percentage change? Like, you have 10 rupee and now it is 5 rupee. So how much percentage change has taken place? First you had 10 rupees, now it has become 5 rupees. So how much percentage change has taken place? 50%, right? So 10 minus 5 upon 10 into 100. 5 by 10 into 100, that means 50%. You won't do 10 minus 5 by 5. There is not 100% change. If 100% change was there, you would have had 0 rupees. But 50% change is there. You have 10 rupees, there is 50% change. That means 10 into 50% of 10. That means 5 rupees. So change of 5 rupees, that means 10 minus 5, 5. So this is what is happening. Your initial voltage was minus 4.91. Your final voltage was minus 2.21. Now, what was your initial voltage? That was minus 4.91. So if they are asking about percentage change, that means they are asking with respect to the initial voltage. Okay. So we just need to calculate this value, minus 4.91 by 4.9. So it is nearly coming around 55%. Okay. So this is the percentage change into 100. So this is the percentage change in capacitor voltage. So this is the answer, 55%. Okay. So you understood the question, right? This was the complete theory given. Very easy question, simple RC circuit question, but you just need to think a bit. Initial voltage, it was minus 4.91, then it was going up to 0. So 0 crossing has to be at 0.42. Then initial voltage was minus 4.91. If the 0 crossing was at 0.22, the initial voltage was minus 2.21. So what was the percentage change? 55%. Okay. So I guess that's it. Now in the next video, we will see RC circuit with current input. Then we will see more circuits. Okay. Then we will see more example of RC circuit like this. Okay. All in time domain we will solve. Okay. Then we will see these examples as well. These are some good examples. Okay. Then we will solve more questions and more concepts we will see. Okay. So I hope you are enjoying the lectures and all the concepts. So in the exam or in the interview, you will be able to solve every single question that they ask. Okay. Every single question. Okay. So if you like the video, please do share it with your friends. So let's move on to next lecture. Thank you.